Good afternoon, dear colleagues. Your attention is invited to a report on the team mathematical models and software for modeling the spread of malware in energy facilities. With rapid development of information technology, the risk of information leakage authorize use of information data substitution and more increased. Modern energy and others industries provide for the management of various objects using automated software. In this one, several models are built which are based on some well-known mathematical models which are described by the system of ordinary differential equations. A mathematical control model has been developed, the purpose of which is to minimize the cost of updating software in an automated control system for an energy facility. In the course of this study, many well-known models were considered, which are shown on this slide. The best result of modeling is spread of malware in real simulation was shown by the last model. In this slide we have a simple model. Model have two time periods. In first period we have two stages S and I, and for this state we have system with two differential equation by S and I. And this in second time period we have four stages and have ordinary system of fourth ordinary differential equation. And in left part of this slide we have initial condition for all equations in time t equal 0. In this slide we have a simple algorithm. This algorithm is Euler algorithms, and we have a simple theme for modeling in MATLAB. In this slide we have mathematical and computer modeling. We obtain a numerical solution to the problem. As you can see, depending on the input parameters of the model, we have different solution. The slide shows interface of the developed software which was developed in the applied mathematical system MATLAB. The second approach of modeling the spread of malware is cellular automata methods. Here are the classic neighbors and grids. And we have some rules for two periods. In first period we have only one rule for grid, and the second period we have fourth rule. In this slide we have a result of modeling with using cellular automata. And here you can see the process of the cellular automata in different points in time. You can see also the general statistics of the distribution of malware. Also the program interface shows graphical dependence of the same statistics. In this slide you can see the result of simulation by cellular automata for other initial condition of the malware distribution process. If we talk about computing and comparing and deterministic model, for example, is a model based on a system of differential equation and stochastic model. A model is based on cellular automata, then it should be note that the result with a good pseudo-random numbers generator are very similar to each other. Based on the basic model for predicting the spread of malware, a control model was built, the purpose of which is to calculate the, and minimize the cost for updating antivirus systems that protect the energy system from malware. In this slide, the following function is minimized. To minimize this function, a classic genetic algorithm was used. Various methods and algorithms can be used to solve this optimization problem. Also, it should be noted that the fund for updating the software are limited, so the control parameters is always limited and in this slide shown the main result of numerical experiments. The numerical values for the model parameters are given at the top left. Below them is the calculate integrand, which gives the minimum of the object functional. On the right are the result of calculation the control parameters. This slide shows the main result of a numerical experiment with other parameters and of the control model. In this slide you can see general conclusions and practical results are given in this slide.